We begin tonight 250 million years ago at the end of the Permian era, the time of the Earth's worst mass extinction. Until now, most of the discussion about global warming has been about its destructive impact on the climate, about melting sea ice, about the potential for massive crop failure, and about the millions of refugees who will have to flee from rising sea levels. And while these things are terrifying in their own right, no one, except for a small group of people in the scientific community, has been recently talking much about the E word, extinction. Well, it's time we started talking about extinction. Because if we continue on the path we're on, if we continue pumping fossil fuels into the atmosphere, it won't just mean the end of the Arctic sea ice or the end of miles of shoreland. It could mean the end of most large, complex life forms on Earth. And that would include us. The possibility that global warming could lead to a mass extinction like our planet has seen 5 times in the deep geologic past is the subject of our new documentary, Last Hours, which we're proud to present in its entirety tonight, right here on The Big Picture.
Consider this, nearly all life on Earth could go extinct because of man-made climate change. It's hard to imagine Earth without life. We take life for granted, but life has not always flourished here. The Earth has experienced dramatic loss of life, or what we call mass extinctions, 5 times over the course of geologic history. Each one of these events has resulted in the loss of more than half of all life on Earth. And the largest and most devastating of all was the Permian mass extinction. Almost all life on Earth disappeared.
Permian mass extinction is, in essence, just the greatest crisis that life on Earth has ever suffered.
By the end of the Permian mass extinction, 95% of all life on the planet was dead. And why is this important today? Because today, a 6th extinction is underway, one that will test the survival of not just human civilization, but possibly of the human species itself. And it bears a horrifying resemblance to several previous global warming-driven events, like the Permian mass extinction.
I think it is certainly extremely significant that a lot of the main crises of the past are associated with global warming, and so with obvious implications for the present day.
When we think of extinctions, we think of the dinosaur-killing KT mass extinction, which was triggered by a sudden catastrophic collision with a meteorite. But the most deadly force behind all extinctions isn't from outer space. It's from underground, underwater, and under the ice, where trillions of tons of carbon lies in wait in the form of frozen methane. If this methane melts and is released into the atmosphere, it will produce a sudden and massive global warming. During the Permian mass extinction, greenhouse gases were released by volcanic eruptions in an area that is today called the Siberian Traps. These, along with the heat from the lava flow itself, warmed the atmosphere of the Earth by at least 6 degrees Celsius. That much global warming took a huge toll on land, animals, and plants, but far worse, it warmed the oceans enough that methane, frozen deep under the sea, melted and was released into the atmosphere. That enormous release of methane, a powerful greenhouse gas, pretty much doubled the level of global warming and killed off over 95% of all life, both on Earth and in the seas.
It's a kind of a scary thought, but maybe one of the best geological analogs for the kinds of rapid changes in climate and CO2 in the atmosphere that we're going to witness now and for the next few centuries, potentially, is this end Permian time when, as you know, that culminated in one of the largest mass extinctions that we know of.
And of course, looking at these ancient events shows us times of global warming, and the atmosphere doesn't care whether the carbon dioxide comes from human activity or from a volcano. It has the same end effects.
The numbers are very similar from some of the giant lava flows in Siberia. The amount of carbon dioxide they release is very similar to the sort of fossil fuel burning carbon dioxide release that we're doing sort of decade after decade today.
Today, carbon dioxide in the atmosphere is above 400 parts per million, a level not seen any time in the history of human life on Earth.
We are increasing CO2 levels in the atmosphere at rates far greater than any of the most rapid events that happened in the deep geological past. There is no precedent for what we are doing to the atmosphere. It is an uncontrolled experiment.
As you warm the environment, that causes the release of more carbon, which is either methane or carbon dioxide, into the atmosphere. That in turn increases the rate of warming, which releases even more carbon. And you can see how this begins to cause a so-called positive feedback, or just an ever-increasing amount of heating.
At the end of 2012, the World Bank issued a report warning governments around the world that a 5-degree temperature increase is likely unless drastic action is taken to curb carbon emissions. And a 6-degree increase was, according to some scientists, all it took to pass a tipping point during the Permian mass extinction. There's a virtual scientific consensus that 6 degrees was all it took to initiate the PETM. In both cases, it involved massive releases of methane.
We know that in the bottom of the seafloor, large parts of the ocean margins have methane in a solid phase. And what happens is that when you change the temperature, it can dissociate, or you can think of as melting this frozen methane phase. And so the idea is that during some of these events, we have some triggering or initial cause that forces the ocean temperatures to warm, especially in deep parts of the ocean. And then that dissociates or melts this solid methane phase, which then goes into gas, which can get into the ocean and the atmosphere.
Methane is way worse than carbon dioxide. It's inert right now in the soil. It's not affecting anybody in any way. When you warm it and it becomes a gas, then it starts acting immediately as a greenhouse gas. So this is an immediate and very short-term threat to planetary civilization.
The risk is a so-called runaway greenhouse, which is the self-correcting mechanism cease to kick in, and you heat by a little bit and you release methane. That then causes excess heating, and you release more methane, and so it goes on.
That's probably the biggest issue that we face. Sea level change is a big one, too, a very expensive one to manage, but the methane release from the tundra, once that gets underway, we reach a point where we lose the option of having an effective mitigation strategy. We can always abandon coastlines, but if we activate enough of the carbon reservoir in the terrestrial biosphere, that becomes unmanageable. So that's unfortunately kind of a doomsday scenario that our trajectory is pointed to.
Most disconcerting, the Arctic ice sheet that keeps the carbon stable is melting rapidly. In July 2013, the Arctic lost 41,000 square miles, an area half the size of Kansas, every single day. And scientists have witnessed kilometer-wide columns of methane gas bubbling up from the ocean floor, suggesting the tipping point to runaway climate change is dangerously close. While it appears we've already passed the tipping point for an ice-free Arctic in the summer, other tipping points could be centuries, generations, or just years down the road. The big danger about tipping points is that you can only recognize them when it's too late to do anything about it. So why should we risk these catastrophic events? In the case of climate change, our planet's life support system is at stake. So it is our obligation to take every precaution to stop it. We must begin to reduce carbon emissions dramatically. Yet, at this moment, we're facing a crisis of world leadership. Powerful fossil fuel corporations are fighting to monetize the trillions of tons of carbon they own that's still underground. The world community, global citizens, governments, leaders, NGOs, and corporations must come together, step forward, and take decisive action. Let's continue the research, but let's not wait until we pass more tipping points. This is the most urgent of times and a most urgent message. Please forward this to as many people as you can. A number of people have endorsed this film, including former Vice President Al Gore, who said that carbon pollution from burning fossil fuels is changing our climate and transforming our world. From more destructive and more frequent climate-related extreme weather events and rising sea levels to climate refugees, crop failure, and water scarcity, the consequences are profound. Al Gore said Last Hours expertly explains how we got here and what will happen if we don't work together to stop it. It is a needed and urgent call to action. Kumi Naidoo, the international director of Greenpeace International, said that Last Hours is a captivating, extremely compelling appeal meant to awaken politicians and business leaders to take climate change action and stop runaway catastrophic climate change. Few films have managed to capture the sense of urgency as well as Last Hours. In the context of science telling us that emissions need to peak by 2015 and then come down, and with politicians doing little to reflect this urgency, this is a much-needed asset for the climate movement. And Maggie Fox, president and CEO of the Climate Reality Project, praised Last Hours, saying that in the 18th century, Edmund Burke wrote, "Those who don't know history are destined to repeat it." Many years later, Last Hours makes clear how much we have to learn from our planet's history to truly understand the potent threat of trapped methane. This film acts as a call to action on climate that we must heed. The stakes couldn't be higher. Share lasthours.org with everyone you can. Tag, you really are it.